This video will be a review for test number 2 for Cal 1. I'm going to work these problems in the order that they fall on my paper. So when you go to take the test, all problems are generated randomly, so nobody will take the same problems at the same time. So problem number 1 for you may be completely different from problem number 1 from everybody else, but you will all see the same types of problems. So maybe let me explain it. As you will all see the same types of problems, they will not just all come in the same order to each of you. So I'm going to work them in the order that they are presented on my paper. Okay? And as I go, I'll talk about the derivative rules. So the first problem that we see on my paper is a word problem. And so when you encounter these word problems, what you want to do is say, okay, first of all, what is it talking about? What formula do I need? And this problem says a spherical balloon is inflating with helium at a rate of 320 pi feet cubed per minute. And we want to know how fast is the balloon's radius increasing at the instant the radius is 4 feet. So the first thing that I want to determine is what equation or what formula do I need? Get that back in focus there. What equation or formula do I need to work this problem out? And since we're talking about a sphere and a balloon, we're going to be looking at the volume of a sphere. And the volume of a sphere is volume equals 4/3 pi r cubed. Alright, once you decide your formula, then what I would do is take the derivative of that formula. Now, when you're talking about these word problems that are talking about rates, all right, all your derivatives are done with respect to time, with respect to t. So if you encounter a variable that is not a t, you're going to have to use that implicit differentiation where, for example, if I take the derivative of v with respect to t, the derivative of v is 1, but because I'm taking it with respect to t and it's not a t, I have to include dv dt with it. Alright, then if I come over here, 4/3 pi, that is a coefficient, that whole thing is a number. So if I take the derivative of r, alright, I'm going to say 3 times 4/3, the 3's will divide out and leave me 4 pi r squared. So this is where I'm using the power rule, where I'm going to multiply by the coefficient by the exponent. So 3 times 4/3 pi would leave me 4 pi. Then I take 1 away from the exponent, leaving 2. Because this variable is not a t, I need to have dr dt. Alright, once you get the derivative of your formula taken, then look in the problem and see what is it that the problem tells you. So anything that has how fast, the rate, it increases at feet per minute, anything like that, those will be substituted for the dv dt's, the dr dt's, the da dt's. Alright, so each one of those corresponds to a rate per minute, how fast, those types of things. So we're going to go through and say, what does our problem tell us? And there should only be one thing that you don't know. Alright, so from the problem, we should be able to fill in for everything except for one thing. And that is what we will end up solving for. So in our problem, it says that the spherical balloon is inflating with helium at a rate, so this should be for something dt, of 320 pi feet cubed per minute. And so since we're talking about the entire balloon, that's going to be our dv dt. So I would say dv dt is going to be 320 pi feet cubed per minute. And it wants to know how fast is the balloon's radius increasing. So we don't, it wants to know how fast is the balloon's radius increasing at the instant the radius is 4 feet. So what we know from that is that the radius, r, is 4. And what it's asking for is how fast. So we should be solving for some type of rate. And since it's talking about the radius, we should be solving for the radius's rate, which is dr dt. So we don't know that. This is what we're solving for. So if I come and I fill this information into my formula, I know that dv dt is 320 pi feet cubed per minute. Then I'm going to say 4 pi times 4 squared dr dt. Alright, and because I'm solving for dr dt, I want to get it by itself. So I'm going to divide both sides of my equation times 4 pi 4 squared, 4 pi 4 squared. And this is also, let's see, this is feet, so that's going to be feet squared. So that'll be feet squared. Alright, so if I take and simplify this out, I'll have dr dt equals, the pi's should divide out, and then if I take 320, I'm going to take 320 and I'm going to divide it by 4 times 4 times 4. So that'll be 4 cubed. Gives me an answer of 5. This is feet squared, this is feet cubed, so that leaves me feet per minute as my answer. Alright, so when you're working through those word problems, make sure that you first determine your formula, take its derivative, then go through and see what is my problem telling me. Anything that says how fast at a rate of feet per minute, seconds per minute, whatever the case may be, those are rates, and those are going to be your dVdt's, dRAt's, depending on the formula, could be dAdt. And plug that in and then see what do I need to solve for. There should be one thing that you don't know. Okay, let's look at the next problem. Alright, this problem says find d sub xy. D sub xy is derivative. Alright, remember there are several different formulas for derivatives. So I could have the derivative of x, the derivative with respect to x of y, or I could have f prime of x, or I could have y prime, or I could have d dx. All of those things are notations for derivative and for the first derivative. So if I'm asked to find the derivative, let me get my problem back down here. Of this problem, all right, when I look at the problem, the first thing I want to note is what is the overarching rule that I'm going to need to apply. So when you look at this problem, there are no plus or minus signs between those two parentheses, so no sum or difference rule in that respect. But these two things, 4x minus 2 to the 5th and 4x minus x to the 5th cubed, are being multiplied together. So the first rule I want to consider is the product rule. Alright, the product rule says take the first and multiply it times the derivative of the second. So let's do that part first. So the first is 4x minus 2 to the 5th, and we want to multiply it times the derivative of the second. So when I look at the second factor in this problem, alright, 4 minus x to the 5th cubed. Alright, this is not a single base raised to a power. This is like an entire function raised to a power. So when that happens, I have to use the chain rule. So the chain rule says we want to take the derivative of the overall function and then multiply it times the derivative of what's inside. So when you look at the overall portion, alright, you have to think of it as this is the mama. Alright, so you want to take the derivative of the mama. Alright, so we're going to say 3 times 4 minus x to the 5th squared. Alright, that's the derivative of the mama. Then you want to multiply it times the derivative of the baby. And that is what is inside. So times the derivative of what's inside. Now this is a difference. So we take the derivative of each thing inside. That is just a 0, so we don't need that, and then that'll be minus 5x to the 4th. Okay, so first times the derivative of the second, and then we add to that the second, which will be 4 minus x to the 5th cubed. So 4 minus x to the 5th cubed times the derivative of the first. Now this, once again, is not a single base raised to a power. This is a function raised to a power. So we'll first take the derivative of the overall part. So we'll bring down the 5 times 4x minus 2 to the 4th power, so kind of applying the power rule, times the derivative of the baby, or what's inside, and that will be 4. Okay, so look at the problem and say, what is the overall thing that's happening? And that is a product. Two things are being multiplied together. The product rule must be used. Then take each individual factor and apply whichever rule is necessary. That would be, in this case, the chain rule for each of them. All right. Now at this point, you want to simplify as much as possible. So when I look at these, anything that's in parentheses raised to a power, you cannot multiply something into that. So like for example on this one, 4 minus x to the 5th squared, I cannot distribute that 3 inside of there. The only time you can distribute it into there is if that was not there. Okay, now these two things right here are not raised to any power, so I can multiply those together. This right here, this one piece, is all one term being multiplied together. So I can say 3 times negative 5x to the 4th is negative 15x to the 4th, and then times 4x minus 2 to the 5th times 4 minus x to the 5th squared. That is one term. Then I'm going to come look at this. Once I hit the plus sign, I'm at a new term. All right, so when I look at these, 4 minus x to the 5th cubed. All right, and 5 times 4x minus 2 to the 4th times 4. I cannot distribute that 5 into there because of that 4 right there. Right? Those are not the same thing. You can't distribute the 5 and then raise it to the 4th power. You will not get the same answer. But these two things I can multiply together. So we'll get 20 times 4 minus x to the 5th cubed times 4x minus 2 to the 4th. Alright, now usually in your homework what I want you to do is look at each of these two terms and factor out a common factor. So when you look at each individual term, this is one term and this is one term. So if you look at what they have in common, so take these two parts right here, it looks like they have in common, and you can pull out a 5 or a negative 5, it doesn't matter. I would just leave it a 5. So I'm going to pull out a 5. Alright, so that takes care of that part. Then when you look at what's left, they have 4x minus x to the 5th, both of them do, and the most I could pull out of each term is 2 of them. So I'm going to pull out 2 4x minus to the 5ths. And then when I look at 4x minus 2, I have to the 4th power and to the 5th power. So the most that I can take out of both of them would be 4. So 4x minus 2 to the 4th power. Now this is my GCF. So what I do is I take and divide both terms by this GCF. I'm not going to write that out. If you want to see that, you can shoot me an email and I'll show you. Alright, so here's what's left. Negative 15x to the 4th divided by 5 is negative 3x to the 4th. Alright, we took out 2 of these, so that's gone. We're taking out 4 of those, so then that is left. 4x minus 2. That takes care of the first term. Plus 20 divided by 5 is 4. 4x minus 4 minus x to the 5th cubed, we took out 2 of them, so that leaves 1 of them. And here we took out all 4, so then that would be what's left. Now sometimes on these problems it's kind of hard to know where to stop. So if you can get to this point right here on the test, alright, and you submit it, if it counts it wrong but you feel it's correct, you just didn't get it factored out all the way, send me an email.